Last time we took the John Dalton's model, the theory. He stated that all atoms of the same element have the same mass, and that they are they are indivisible. But later it was like scientific advances, they allowed scientists to explore it, and it became clear that like there are smaller particles in an atom, and it is indivisible because there are smaller particles. And that the number of and arrangement of this particle within an atom, it determines the properties of this atom. So today we define an atom as the smallest particle of an element, and it retains the chemical properties of that element. They consist of two regions, the nucleus, which is a very small region, and it is located here in the middle of an atom. This nucleus, it is made up of at least one positive charged particle that is called a proton, and it's usually and then there's another particle, it's called a neutron, and this particle, it is neutral, it does not have a charge. And surrounding this nucleus, there is a region, it contains negatively charged particles, and these are electrons. Positive and negative particles in an atom. How were the subatomic particles discovered? The first discovery of the subatomic particles was in the late 80s. Some experiments at that time in which like the electric current was passed through glasses at low pressure, and it was carried down a narrow glass tube attached to a vacuum pump. This is known as a cathode ray tube. Investigators noticed that when the current was passed through this tube, the surface of this tube directly opposed the the surface that directly opposed to the cathode, it glowed. And then they were curious about this, so they had a hypothesis that the glow, it was caused by a stream of particles, which they called a cathode ray. The ray, it traveled from the cathode to the anode when the current was passed through the tube. And the experiments devised to test this hypothesis revealed some observations, which is that cathode rays were deflected in a magnetic field in the same manner as like a wire carrying an electric current, and this was always known to be a negative charge. The rays were deflected away from a negatively charged object, which means that this glow, it had negatively charged particles or objects too, because it deflected away from the negatively charged object in the experiment itself. So these observations, they led to the hypothesis that
That's great work, Yara. Really, I'm so proud of you.
Miss, can you hear me now?
Yes, I can hear you, my dear.
And they led to the hypothesis that the particles that compose cathode rays, that there were negatively charged particles in this glow, and that the ratio was always the same regardless of the material used to make the cathode or the nature of the gas inside the cathode ray. So it has nothing to do with the things in the experiment itself. However, there is another negatively charged thing that is acting in this experiment. And then after they concluded this, they called this negatively charged particles electrons.
Very good.
And then here J.J. Thomson came and said that after the experiment of the cathode ray tubes, he showed that all atoms contain tiny negatively charged subatomic particles or electrons. Thomson, he proposed a model, and he called it a plum pudding model of the atom, and which had a negatively charged electrons and that are embedded with a positively charged, like positively charged soup. It's like a soup because it's like all gathered around. It's not in a particular arrangement.
You mean they are mixed throughout, like
Yes.
a solution? Yes. Okay.
And then there's another scientist after J.J. Thomson. He's called Rutherford. There was one day, him and a group of scientists, they were doing an experiment in which they boarded a thin piece of gold foil with a moving alpha particles, and these particles were positively charged, with about 4 times mass of hydrogen atom. And they assumed that mass and the particles at beam of one would expect from the plum pudding model, because they expected from the plum pudding model that the particles will just pass through with only a very slight deflection. And for majority of the particles, this was the case, but they realized that that there was a lot of wide angle deflections. And they were very shocked to see that, because they were following the J.J. Thomson's model. They found roughly in 8,000 of the alpha particles had actually been deflected back toward the source. And then after a few months, Rutherford stayed thinking, and finally he came up with an explanation. This explanation was that deflected particles must have experienced some powerful force within the atom. Like if you take a ball and then you throw it on the wall, because there is a wall, it will go back to you. That's what he thought. Because so few of the total of alpha particles had been affected by it, and that the force must be caused by a very densely packed bundle of matter with a positive electric charge, because the thing that deflected back, it was also positively charged. Rutherford has discovered that the volume of a nucleus was very small compared to the whole volume of an atom. Like, in fact, if they want to simplify it, they said that the nucleus, it was a size of a marble in a football field. Like, the football field is the atom and the nucleus is the marble. So it was
Yes, Yara. Yes, so I can conclude from your previous slide that the nucleus is occupying small size from the whole atom, like a marble in a football field or system. It explained the volume of the nucleus, a small volume. But previously, just you mentioned that it's very dense. So it is like concentrated region inside the atom, but occupying small space or low volume, small volume, but it's very dense. Excellent,
Yes.
Yara. Very good. I'm so proud. Next, poor suggestion.
Then there was a student of Rutherford. He was called Bohr. Because Ruther's model, it did not say anything about the electrons, but then Bohr came and proposed a model, and then in this model, the electrons they surrounded the positively charged nucleus, like the planets when they surround the sun. I put his picture and his model suggestion. Then here we talk about the properties of the subatomic particles. Like, except for the nucleus, of the simplest